Woohoo and welcome back. Today we're going to be talking about 1.6 and specifically about supply and demand. Woohoo! Yay! So let's go over a couple of definitions. Supply, the number of units the company or market is willing to produce at a given price. Demand, the number of units that consumers are willing to buy at a given price. Market equilibrium, a price and quantity where supply equals demand. So in other words, this is when both sides of the economic transaction get along and they're both happy about the situation. Surplus, this is a situation where demand is less than supply. So we've got more stuff, not enough people want to buy it. So demand is less than supply. There are units left over. A shortage, there is a shortage when demand is greater than supply. So people really want to buy something, but there aren't enough of it to buy. So there aren't enough of the units to go around. So a shortage, what you want to think about in terms of perhaps Black Friday, when everyone's trying to buy that same TV that costs 32 cents. A surplus, you want to think about the day after Halloween or the day after Valentine's Day when there's a bunch of leftover chocolate in the store. That's going to be a surplus. So let's talk about a very specific example from the book. If the demand function for Z brand phones is P plus 2Q equals 100, and I'm going to stop right there and let's take a look at what we've got. This is demand. P plus 2Q equals 100. Now, nobody's saying anything about what P and Q are, but hopefully it is fairly self-evident that P is going to stand for price, and if it's not, then I'm telling you right now, P is the price, and Q is the quantity. So in this case, the quantity demanded times 2 plus the price is 100. Okay, and then the supply function is 35P minus 20Q equals 350. And you'll see we've got P and Q still. And so what we want to know is what happens when price is 14, right there, when price P equals 14. So if P equals 14, and we're assuming that's in dollars, although we don't have to. In this example, this could be 14 pounds, 14 yen, it could be 14 anythings. So 14, I'm assuming dollars. Then the demand looks like this. Where the P was, we plug in 14. And then we can go ahead and solve for Q. Let me scooch this forward a little bit. There we go. I can subtract 14 from both sides, and I get 2Q equals, I think that's 86, or in other words, Q is 43. I divide both sides. So the quantity demanded is 43. So far, so good? Now let's look at the supply side of things. The supply equation is 35P minus 20Q is 350. And I'm going to need to get out a calculator for this one, I think. Okay, so my calculator's at the ready. I've got 35 times 14 minus 20Q equals 350. Okay, so 35 times 14 is 490. Minus 20Q equals 350. This is not a fun equation to solve by any stretch of the imagination. You could do it a couple different ways. I'm going to go ahead and just brute force it. So I'm going to subtract 490 from both sides. And I'll get negative 20Q equals And I believe this is negative 140. There's no shame in checking that on a calculator. And then I've got negative 20q over negative 20 equals negative 140 over negative 20. And even though it's really, really, really small, I get q equals 7. So the quantity demanded is 43, but the quantity supplied, this is the supplied side, supplied, there's only 7. So in other words, people want to buy 43 of them, but the suppliers only want to make 7. Now, why is that? Well, at a given price, so if this is $14, all the consumers are like, holy cow, a phone for $14? Sign me up, I'd like 12, right? Because it's a really low price. So consumers are very happy about this. But from the supplier's side, they're looking at it thinking, wait a minute, I can only sell this phone for $14? I'm not going to be able to make a lot of money, and this is going to be a waste of my time. So they're not willing to commit to as many. And so what happens? Demand is greater than supply. And so are there surplus phones, or is there a phone shortage? And the answer is there's a phone shortage. The quantity demanded is 43. The quantity supplied is 7. Demand is greater than supply, so there's a shortage. Now, this is an example of a problem where I didn't find, pardon me, let me put it up there so you can see everything. There we go. I didn't find the equilibrium. I did not find that price that would balance out. I just went ahead and plugged in what would happen to demand and what would happen to supply and compared them. So, what about looking at the more broad situation? So, here's another example. We're given a graph, and in this case, because we're in a chapter that's all about linear functions, demand and supply are linear. In the real world, I'm sure you can imagine that supply and demand aren't always exactly lines, but we can think of them as lines and we can approximate them with lines. So the first problem, this is a new problem, not the same one. We have to go through, if we're given this graph of supply and demand, and we have to identify which line represents supply and which line represents demand, assuming this is not a luxury good. And so the first thing we need to do is take a look at the two lines. The red line, which goes up, shows that as quantity goes up, so does price, right? So the quantity 1 for $1, 2 for $2, 3 for $3, 4 for $4. So the price is going up as the quantity goes up. As quantity goes up, price, and I'm going to write the whole word out because I know P is tricky in economics because P can be a lot of different things. In the blue line, let's take a look at what's happening there. Oh, it's not quite the same blue, but hopefully. So this line heading up, this line's this one, and this line is this one right there. Now this one, when the quantity is 1, the price is way up here at $9, but then for 2, the price is 8. 3, the price is 7. So as quantity is going up, we're noticing price is going down. So as quantity is going up, price is going down. So in one of these two, quantity and price are going up together. And in the other, quantity and price are in opposition. They're moving in opposite directions. So let's just think about it for a second. If you are a consumer, and if you are thinking about spending some money, and you're gonna buy, say, a burrito. Where's my burrito? There's my burrito. I'm gonna move this away for a second. If we have a burrito, okay, and you want to buy this burrito, and I tell you the burrito costs $1, are you going to buy this burrito? And the answer is yeah, unless you're worried, unless you're like, wait, why is it only $1? But if I say it's $5, you say, yeah, okay, I'll buy that burrito. If I say it's $20, you're gonna say, wait a minute, what's so special about this burrito? And if I say it's $1 million, you're gonna say, whoa, that's too much money for a burrito. So if you're buying a burrito, as the price goes up, the quantity goes down. See the quantity going down? It's a teeter-totter. As the price comes down, the quantity goes up. So if I tell you there's a sale on burritos, boop, as the price goes down, the quantity goes up. That's for consumers. Consumers have quantity and price in opposition. So for a consumer, where did it go? We get something called the demand curve. Price and quantity have an inverse relationship. As the quantity gets bigger, the price gets smaller, and so we have a negative slope. Okay. But what if you're selling burritos? Well, now, if you're selling burritos, it's a slightly different story. And in this slightly different story, what I'm going to say is, I just heard that you can make $3 selling burritos. And then you'll say to me, okay, but that's a lot of work for $3. I say, okay, but I heard you can make $10 selling burritos. And now some people are going to say, wait a minute, I do that. That's a good deal. I want to make $10 making burritos. And then if I said you could make $100, imagine I flickered my fingers 10 times. If you could make $100 per burrito, I think a lot of people would run out and say, okay, I'm going to start making burritos. So if you're the supplier, watch this. Isn't this so cool? Look at this technology right here. No expense spared in these videos. So if you're a supplier, as the price goes up, the quantity goes up. As the price comes down, the quantity comes down. So for suppliers, the price and the quantity move together. And so a supply curve for burritos or for anything is going to look like this, where price and quantity have a positive relationship. That slope is positive. The line goes up. Okay, so let's go back to our paper. We're going to move the burrito. And let's see what we can figure out from this. Sorry, Sharktopus. There we go. So if the quantity goes up with the price, that's the supply side. This is supply. If they move together. If they move in opposition, as the quantity goes up, the price comes down. So it's a negative slope. Then this is demand. Okay, so this is demand right there. And this is supply. Woohoo. And we usually just write D and S, so that's pretty consistent in economics. Next question. If the price is $7, what quantity is demanded? Okay, so we got to find the price. The price is $7. Remember, it's up here. So let me draw. If the price is $7, here's $7 right there. Okay. If the price is $7, what quantity is demanded? Here's our demand curve. Is this one the one that's going down? So that's right here. And that is 3. So whatever this is, I don't know, maybe it's burritos. So for $7, you could sell 3 burritos on this particular day in this particular market. Okay. If the price is $7, what quantity is supplied? Okay, so now we want to go look at the supply side. Here's $7 comes over here. That's right there. That is, there are 7 supplied there. So the point on the demand curve is 3, 7, and the point on the supply curve is 7, 7. So is there a surplus or a shortage when the price is 7? And the answer is, we've got 3 that people want to buy, 7 that suppliers want to make. So they made too many, right? Demand is less than supply, so there's a surplus. Like Halloween candy or Valentine's Day candy the day after the holiday. There's just too much. So not that many people want to buy it because the holiday's already passed, but there's more of it in the store. Suppliers have made a bunch. So there's a surplus of 4 units. Okay. Now, what is the market equilibrium? Where the heck is the market equilibrium? Let me call that one yellow. Market equilibrium. So we want the point where supply and demand are on the same page. They're in exactly the same spot. So what does that mean? That's this guy right here. See that right there in the middle where the 2 lines, supply and demand, intersect? I know, that was beautiful. Right there is the market equilibrium. So what's special about the market equilibrium? Well, that is a point that is on the on the supply curve and on the demand curve. It is at their intersection. So it makes the consumers happy and it makes the suppliers happy. Now, what is the intersection? Well, as it turns out on this one, it's kind of cool, and I totally ruined it because I drew through it, but hopefully you can see. The coordinate here in quantity is 5, and the price is also 5. So the quantity, which is basically the x value, is 5, and the price, which is effectively the y value, is $5. So if they lower the price to $5, what happens? Well, back here, the price was $7. At $7, people only want to buy 3 of them. It's too expensive, right? If there's a surplus, it's too expensive. What do they do right after the holiday? What do you do when you've got a bunch of Halloween candy left in the store? You put it on sale, right? You lower the price. So we lower the price down to $5, and then people want to buy 5 of them, which is exactly what the supply side wants to do. In this moment in time, for $5, they'd be happy to provide 5 of these items. So you've lowered the price. You have managed to match up both demand and supply. Nicely done. Woohoo. Okay, so next up, we'll do some more examples with supply and demand. Woohoo! Math on, and have a great day. And now I want candy.